Hi guys, welcome back to my channel. So I hope you're doing well. So in this video I'm gonna discuss out the problem shortest prime paths, which is problem of the day of Geeks for Geeks. So this problem looks very tough at first sight, but I will explain you in the easiest way, and you will get why to use BFS here, because most of us are facing problem in understanding these kind of problems, that how we are using, why we will use BFS here. So I will explain you everything, don't worry. So first give it a read. You are given two numbers, num1 and num2, and we have to find the shortest distance between num1 and num2, and we can alter any of its digit, and after altering that digit, the new number formed should be a prime number. Always should be a prime number. So this is the constraint that we have given. Now look at this example. You are given the first number 1033, second number 8179, and we have to go from 1033 to 8179, so we can alter any of the digits. So for example, here 0 is changed to 7, and this must be a prime number, so this is a prime number. And then we have changed this 1 to 3, then we have changed this 3 to 9, and then we changed this 3 to 7, then this 3 to 8, then this to 1, and finally we reached our destination in 6 steps. So we have to return this. Now I will explain you how we can use BFS to solve these kind of problems. So let's move to the next screen. So now guys, let's understand this pattern and you will get why we are using BFS here. So you will get the intuition here for using BFS. What we are doing, we are at this number 1033, and what we can do here, we have to replace every digit from 0 to 9. So for first digit it is 1, so what we can do, we can change it to 2. So I have changed it to 2. Then for second digit we have 0 here, and we can change it to 1. And for the third digit we have 3 here, so we can change it to 4. And the final digit is 3 here, so we can change it to 4. So changing to all of these digits will give us will take one step, and it is also on the level 1. So it seems that we can use BFS here. This will give us intuition of using a BFS. And similarly for the next step, what we can do, we can change this 2 to 3, we can change this 0 to 1, we can change this 3 to 4, or we can change this last 3 to 4. So it will give us level 2. And suppose at somehow we will reach this 8179, and this will be the level k. Then what will be our answer? Our answer will be level k. That is the steps required to reach here, and we have to return the minimum number of levels to reach here. So we can try all the possibilities from there, and finally if we reach 8179, then it will be that level be the answer of our problem. So the one more constraint is given in the problem, that each of these numbers should be a prime number. And for checking this, we can use sieve algorithm. If you have no idea about sieve, then you can watch my another video. I have pinned the link in the comment box for sieve algorithm. You can check out from there, or I will give the link in description box also, so you can check out from there. So this gives the idea about why we are using BFS here. So let's move forward and see the code. So friends, after watching the intuition, I suggest you to try this problem on your own. And if you are not able to solve the problem, you can come here and watch the code. So let's start. First of all, we need to find the primes. So for that, I'm using sieve algorithm. If you don't know anything about sieve, then don't worry. I provide the link in the description box where I taught the sieve algorithm. So you can watch from there, or you can also watch. There are many tutorials available on YouTube. Sieve is nothing but it creates an array of primes where every index denotes that number is prime or not. Suppose the index number 5, so it will denote that the number 5 is prime or not. That's why I am taken this. You can use this boolean also. Now what we have to do, when we have created this sieve algorithm, this prime array, after that we have to run a BFS. If you are not familiar with BFS, it might be hard for you to understand, but I will make it easy. Don't worry. Please watch this video till last of this and you will understand how to use BFS. What we have to do, we have created a queue which will store the steps and the number, as I shown you in the intuition, that what we have to store, we have to store the new number with their level. so that we can understand how many steps we have to reach the target, and we have to return that steps. And we have also took a visited array, so that we will not explore the same visited array again and again, and will stuck into the infinite loop. That's why we are using a visited array here. Now I have pushed the a with the step 0, because the first number is on the level 0 and every number will come after it will be of level 1 or one level more than that. That's why this is what number and level. We have to push in queue the number and the level. So current level is 0 because it is the starting number. And now while queue is not empty, we are taking the element from front of the queue and then popping that element, and the number will be the first of this element, and the distance means the level will be the second of the element. Now we will visit that number that we have visited this number, and if the target is achieved, suppose this number is the target and we reach the target, then we will return the distance, this level at which we have reached till now. If we have not reached the distance, then what we have to do, we can replace any of the digits of this 4-digit number. So we are trying every possibilities from 0 to 4. We are replacing every digits with 0 to 9, but they are saying that we cannot use leading zeros. That's why if the index is 0, then we cannot use 0 again. So I'm doing a continue here to skip the process. Now we have to change the string. We have to change the digits, so it is not easy to change the digit in a number. That's why I have changed this into a string, and changing the digits into the string will be far easier than changing the digits into a number. Then for this index, suppose at 0th index we want to change the digit to this, we can use this method. This will create a number, a string of that number. You can understand this by ASCII value. This is nothing but we are adding 0 plus this number, and it will create the ASCII number of that number. Suppose you have added 3, then it will make the ASCII value of 3 and add it to the string. So now we are doing what? After converting this string, we are changing again it to the number and checking if the number is prime, then we will push it into the queue. If it is not prime, then we don't need to push it into the queue, because we have to move only on prime numbers. And if it is not visited, then only we will visit it. And then we will push this number, and the distance will be the level plus 1, previous level plus 1. Previous level was what? Distance. This was the previous level. So now we have to move forward with this level plus 1, and we have to mark visited this array, this number. So for every number that you will get after interchanging the digits, you have to put it into the queue only if it is a prime number and it is not visited. So that you can see here, we are checking if it is prime, then only we will push it into the queue, because it is given that we have to step only on the prime numbers. And we have to repeat this process while queue is not empty. And if anywhere we will get the target, that is B, the second number that we have to take, if anywhere we will find that, then we will return the current distance, as I have explained you into the intuition. So I hope guys you will understand this, and if you have any doubt, then feel free to ask in the comment box, and please subscribe to my channel so that I will upload more these kind of solutions. Bye bye guys, see you in the next video.